right, so we're going to be doing number 1. We did this in class today, actually. Okay, the first thing we're going to look at it is, right, this is the fourth root, looking up for the fourth root of this whole expression here. Okay, so the key thing is anything that repeats 4 times comes out of the radical, right, or there's multiplication of 4 times when looking at the factorization tree. Okay, so we're going to do the factorization tree, the prime factorization tree. Okay, so if we break down 625, okay, 625, the factors of 625 is 25 and 25, and then the factors of 25 is 5 times 5, 5 times 5. So we see that the prime factorization of 625 is 5 to the 4th. All right, there's multiple multiplications. 5 is being multiplied by itself 4 times, so therefore the 5 is going to come out the radical. So we put the 5 outside, and then we have to determine what's going to stay inside. Okay, we look at x to the 4th. Well, x to the 4th is equal to x times x times x times x. So we see the x is repeating 4 times. It is x to the 4th. Okay, so the x is also going to come out the radical. All right, now let's go look at y to the 6. Y to the 6 can be broken down as y to the 4 times y squared, and y to the 4th is y times y times y times y, right? There's a multiples of y 4 times, or y to the 4, so the y is going to come out as well. And y squared, there's no power of 4 there, so y squared stays in the radical. Okay, now we need to convert this into having a rational exponent. So we're going to have 5xy, okay, so it's going to be times y to something over another number. So this refers to the root of the radical. The number in the top refers to the power of the radical. In this case, the root is 4 and the power is 2. Okay, so now we have 5x to the y times y to the 2 over 4. Well, we simplify, it becomes y to 1/2, and we can actually combine these terms here, right? They're the same base, and we add the exponent, so we're going to add the 1 that's here and the half. Okay, so if we do that, even if you do that in your calculator, okay, let's see what comes up. Yeah, calculator. If we do 1 plus 1.5, and if we do math, enter, we get 3 over 2. Okay, so this becomes 5x y to the 3 over 2 power. Okay, so that's our answer there. That's for number 1. Okay, number 2, we need to be able to convert that into radical notation. Okay, we see that the 4 is the root, so we put the 4 there on the radical, and we also see that c is the power. Okay, so that whole thing is going to be raised to the c power, and we put 3b there. So that's how we convert from a rational exponent to radical notation. Okay, so that's it right there. To find out the remainder, okay, so when you're looking at the remainder, look at the remainder theorem. So the remainder theorem says that if we take the polynomial is being divided by x minus 4, okay, and then we take the inverse, or the opposite sign of the negative 4, okay. Okay, if we look at this right here, okay, that's negative 4, but we do the opposite. Okay, we get substitute, say x equals 4, and we substitute that into polynomial, so we'll get 2 to the 4 to the 3rd minus 5, 4 squared minus 11 times 4 minus 4. Okay, so if you do that and you put that in the calculator, okay, so there you go. Okay, put that in the calculator. So that's going to be 2 parentheses 4 parentheses raised to the 3rd power, hit the right cursor there, minus 5 parentheses 4 squared minus 11 times 4 minus 4, that gives us a remainder of 0. So what is the remainder? The remainder is 0. Based on that, x minus 4 is a factor of the polynomial. Okay. So considering what statement about this graph is incorrect, talking about even and odd polynomials. Okay. All right. So determine about even and odd functions. So this is how you determine it here. If you substitute for even, if you substitute the negative x and the positive x, they're going to be equal to each other. Okay. So if we look at over here, see, this is an even function here. So if I look at the negative x and the positive x, note it's going to be equal. Okay, it's going to be equal. However, if I get the negative x, okay, over here, and I look at the positive x here, notice it's going to be negative. That's going to be positive. So it's actually the negative, or change the sign of that. Okay, so that's pretty much how even and odd functions work. So if we look at this example here, I want to determine whether this is an even function or not. Okay, I want to determine whether that's an even function. Okay, let's look at it. It's a good review. So I'm going to try, let's say, I'll try f of 2. I'll try f of 2 and f of negative 2. Okay, if it's even, this is going to be equal to each other. If it's not even, then they're going to be the negative of each other. They're going to be pretty much the same with the signs change. So let's say, so we say 4, 2 squared plus 11, 4 times 4 plus 11, 16 plus 11, that's 27. And then 4 times negative 2 squared plus 11, that's 4 times 4 plus 11, 16 plus 11, that's 27. They're equal, so therefore this is an even function. Okay. Once again, the even functions look like this. Okay, they're pretty much symmetrical. And then the odd function, it's really kind of a reflection through the point, through the origin. All right, and then neither, it doesn't have none of them. So that's how you see whether it's even or odd. Okay. All right, so now let's continue. Denominator is equal to 0. So if we do this, x squared plus 7x plus 10 equals 0. Okay, we got to look at the factors of 10 that add up to 7. In this case, it's 2 times 5, and 2 plus 5 is 7. So we have x plus 2, x plus 5. So that means x is negative 2, x is negative 5. Essentially, you take the opposite sign. Okay, so you're going to do x equals negative 2, x equals negative 5. Okay, so that's when this function is undefined, when x is negative 2, x is negative 5. All right, let's go on to the next. All right, complex number, complex form. So we're going to identify A is 2, B is 3, C is 2. I use my formula, negative b plus or minus b squared minus 4ac divided by 2a. So we're going to substitute negative b plus or minus square root 3 squared minus 4 times 2 all divided by 7. So b should be 3, and then 2 times 2. Okay, so we evaluate that. That's going to be negative 3 plus or minus that's 9, 8, 16, or 9 minus 15 is negative 7 over 4. That is equal to negative 3 plus or minus square root of 7. Okay. Yes. 7 over 4 times square root of negative 1, right, to get that negative. So that becomes our I, right? This becomes our I here. And so we have, our answer is going to be negative 3 plus or minus I square root of 7 over 4. Okay. All right, for this one, right, radical by itself. We want to get this guy by itself. So we're going to move the x over. The x moves over, it becomes negative x. We got square root of x minus 5 is equal to 7 minus x. Then cancel out the radical. So we're going to square both sides. When we square both sides, the radical cancels out the power of 2. Sorry, the power. When we raise it to the power of 2, that cancels out the radical. So we get x minus 5 is equal to 7 minus x squared. That is equal to 7 minus x. 49 minus 7x minus 7x, x squared. So that is equal to x squared minus 14x plus 49. So now we have to move that x over. When we move it over, it becomes negative x. So negative x comes over. Negative 5 comes over as positive 5. So that becomes x squared minus 15x, right? Negative 14x minus x is negative 15x. 49 plus 5, that is 54. Okay, so what we just did, write in standard form. And now we're going to have to solve x. I'll charge my phone, charge the battery. Okay, so yeah, so then that brings us to, so we are going to find the factors of C, right, and add it to B. So factors of 54 that sum to negative 15. So that's going to be negative 9 times negative 6. Negative 9 plus negative 6 is negative 15. So that becomes x minus 9. X minus 6 equals 0. So x equals 9. X equals 6. Okay. We want to check for, so after we write in standard form, we solve for x. And then we're going to check for extraneous roots. So if I do that, looks like that works actually. Okay. I want to check for extraneous roots. For x equals 9, x equals 6. We do square root of 9 minus 5 plus 9 equals 7. So we get square root of 4 plus 9 equals 7. 2 plus 9, 2 plus 9 is 11. Oh, 11 is not equal to 7. So actually we eliminate this. X can't be 9. Let's check for 6. 6 minus 5 plus 6 equals 7. Square root of 1 plus 6 equals 7. 1 plus 6 equals 7. 7 equals 7. That is correct. Okay, so that's our answer there. Okay, let's go to this one here. B in this case is just combining the denominators and the numerators. Okay, so the LCD is going to be p plus 3, p minus 5, and then multiply each fraction by LCD. So we're going to have 3p, p minus 5 times the OCD, which is p plus 3 times p minus 5, minus 2 over p plus 3 times p plus 3. Right, we got to multiply every fraction by that, and then equals p over p plus 3 times p plus 3 times p minus 5. Okay, so that's the LCD that we're multiplying each fraction. Okay, so what's going to happen? The p minus 5 cancels out the p minus 5, p plus 3 cancels that p plus 3, this p plus 3 cancels that p plus 3, and then what we have to do is multiply 3p times p, and then 3p times p, 3p times 3, and 2 times p, etc. We have to multiply that out. So when we do that, 3p times 3p, 3p times p is 3p squared. This is 9p minus, that's going to be 2p minus 10. And then this is going to be p squared minus 5p. Okay. So we have to distribute that negative, so that's going to be 3p squared plus 9p minus 2p plus 10 is equal to p squared minus 5p. So after step 2 is to multiply. Okay, next step is write in standard form. Okay, so we're going to move this p squared over to the other side. The equal sign is minus p squared. We're going to move this as positive 5p. So that becomes 2p squared. 9 minus 2 is 7. 7 plus 5 is 12. Right? We add this. Right? Those are like terms. That's 12p plus 10 equals 0. We can divide the two. So we got p squared plus 6p plus 5. Okay, so now we're going to get the factors of c to add it to b. So factors of c to add it to b is 5 times 1, and 5 plus 1 is 6. Okay. Okay. And so that becomes x plus 5, x plus 1. And so we get the opposite signs there. So x equals negative 5, and x equals negative 1. Okay.